Hello everyone, I hope you're doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day, and today's problem is binary matrix having maximum number of ones. So it is an easy level problem, and it says we have been given a binary matrix consisting of only zeros and ones of the order n into n. All rows are sorted already, and we need to find the row with the maximum number of ones, also find the number of ones in that particular row, right? So we have to return the row which has the maximum number of ones, and how many ones does it exactly have. We have to return that information also. Now the question is pretty easy, very easy. If you look at the constraints, it says that the n is up to 10 raised to power 3, right? So we can definitely solve this problem in n square approach. And if we try to solve this with n square approach, then this particular information, all the rows are already sorted, it's not very useful. It is not for us. But now we are not going to discuss the n square approach in today's video, because that is just very simple, and I'll just explain it that you can just iterate through all the rows one by one, and at each row you can initialize your counter to 0, count how many ones are there, and if the number of ones are greater than the maximum number of ones you have encountered till now, you can update that particular value. So that is pretty simple, but we want to solve it in this particular expected time complexity O of n. And here is when this particular information that all rows are already sorted comes into picture, right? This information is only important when you want to solve this particular question in O of n, right? So we are going to discuss the O of n approach in detail, how we can solve it in O of n. Even the O of n approach is not very difficult. It's just that it's not very straightforward like the previous one, right? The second approach is also very easy. I'm going to explain you how we can solve it in O of n. So our goal is to make the most efficient solution for this particular problem, and that is an O of n time complexity. Now the basic approach is to first of all, let me just explain you the test case. It might be apparent. The answer is pretty simple. So this is row number 0, this is row number 1, this is row number 2, and since this particular row has maximum number of ones, so we will output the row number as well as the number of ones, that is 2 in this case, right? So this will be the answer for this particular test case. Now how are we going to solve this question in O of n? I said that this particular information that rows are sorted is very important in this case if you want to solve it in O of n. So rows are sorted. This is a very important information for us. So how is it important? Now the approach is to start from this particular position, that is the top right cell, right? The topmost and the rightmost cell. Now what we do is we just check if it is equals to 1, right? So definitely it is equals to 1. Now I move on to the cell just next to it, that is to the left of it. Now I check 0. Now it is 0, so that means it cannot contribute any more to the answer. The maximum this particular row could have contributed is actually 1 only, because there is only a single one. And since we already know that these rows are individually sorted, that means that there will be no ones present after it, so we don't need to worry about them. Once we have encountered a 0, that means this was the only one that we have till now. So what we instead do is, we have encountered the maximum number of ones, we just update our answer that okay, at row number 0 we have found one number of ones. Now we move on to the next row, right, to find our answer. In the same column we move on to the next row. Now as soon as we find one, that means in the previous row there was only a single one, now we have found one more one. So what we'll do is we'll quickly update. As soon as we found a new one, we'll update our answer, that is we have found a new one at row number 1 and the total counter has become 2 now, right? So again, when we have encountered this particular position, now we move on to the left in search of a new one. Since we have found 0 here, now we cannot take it because it is a 0. So what we do, we just try to check for the next row. So we move on to the next row in this particular column. Again we have not found a 1, we move on to the next row. We keep on doing this, but since there are only 3 rows here, we will not be able to move on to the next row and our program will terminate here. So the basic idea is, start from the top right cell. If we have encountered a 1, we move to the left to look for a new one. If you have again encountered a 1, we move to the left, right? Now if for example, if there was 0 here, if we have not found anyone here, we have found a 0, then we know that there will be no more further ones present to the left of it. So we move on to the next cell. So if there is a 1 here, I don't need to check these many cells, because these will be already ones, because the whole row is already sorted. So if there is a 1 here, I don't need to check these cells, right? Because they would be already 1. I don't need to check them, right? So what I do is I just check the latest cell, that if this is 1, that means I found 3 number of ones. I update my row and column data, right? So but if it was a 0 here, let's say if it was a 0 here, if it was 0, I would move on to the next row, right? Next row again, let's say if I found a 1 here, then in this particular row I move on to the next cell, just to find that if there are any more ones left or not, right? So if I find a 1 here, well and good. If I don't find, I move on to the next row, right? I keep on moving to the next row until I find a 1. As soon as I find a 1, I just move to the adjacent column, right, to find a new one. So I'll just keep on doing this and keep updating my row and column value as soon as I find a new one. So this approach will work in O of n, and the worst case complexity, let me explain you. In the worst case, what will happen is you are starting from this particular cell, right? You will move on to the bottom cell, right, in a straight away manner, and then you will move on to the leftmost cell. In the bottom row, you will move on to the leftmost cell. Like this would be the worst case. So in this case, you have traversed n here, you have traversed n here. Total worst case at the maximum case would be 2n, which is effectively O of n, right? So this would be the solution for today's problem of the day. So this approach was also very easy, but like this is not very straightforward like the previous one. It's a start, but it is not very difficult to understand as well. So let us discuss the code now. So what is happening in the code is I have initialized two variables, max count and max row. So this will be storing my answer, right? And I have initialized my current row with 0. So I just initialize my I. So this will be acting as a column. So this will be from n minus 1 till it is greater than -1 and I minus minus, right? So I just do while current row is less than n and the matrix that has been given to us in the input, the current row and the ith column is not equals to 1. So until it is 0, I just keep on incrementing my current row in order to find my next one, right? So in this way, I am just incrementing my current row. Once I have found a 1 or I have exceeded the value of n, that means I am out of the box now. I just break out of this while loop, and first I check whether my current row is greater than or equal to n. That means if I like break out of the set box, then I can just break out of the for loop. Otherwise, what I do is, it means I have found a 1 inside that box. So I'll update my max count with n minus I. So this will be, for example, if I is 0 here, 1 here, 2 here and 3 here. If I found a 1 here, that means these three rows will also, these three columns will also be 1. So n, the value of n is 4 here, and if I subtract 1 from it, so the answer will be 3, right? So this is how I'm finding the number of ones in this particular row. So I just do n minus I, and I update my current maximum row, the final answer row, as current row, right? So I just keep on doing this until this for loop executes, and at the end, what I can just do it, I can just store my answer like this in a vector, because it asks us to return a vector. So I initialize my answer vector with max row and max count as the elements, and I just return my answer vector. So this was the solution of today's problem: binary matrix having maximum number of ones. And this was a pretty easy problem for today, and I hope you guys were able to understand this optimized approach. I didn't want to discuss the n square approach because that is very basic, and I believe like the O of n approach is what you will find interesting. I hope that this video was useful for you. If you found this video useful, then you can consider subscribing to this channel. So till the next video drops, keep coding, stay safe, bye bye.